Hello everyone and welcome to this video. Today we are going to learn how to simplify problems that have exponents inside and outside of a parentheses. In other words, we are dealing with exponents raised to more exponents. Let's take a look at this. To be able to master these problems, we first have to understand the basics of exponents. For example, if I give you 4 squared, you should know that that's 4 times 4. If I give you 4 to power negative 2, you should know that that's the same thing as 1 over 4 squared, or 1 over 16. Also, if I give you 5 to the power of 2 times 5 to the power of 3, you should know that you add the exponents, and that gives you 5 to the power of 5. And lastly, if I gave you 5 squared times 5 to the negative 3, that gives you the same thing as 5 to the negative 1, or 1 over 5. If any of these concepts are new to you, I recommend you check out some of our previous videos breaking down the fundamentals of exponents. All of them will be linked in the description below. So now let's take it to the final step of exponents raised to more exponents. For part A, you have 4 squared all raised to the power of 3. Whenever you have a problem like this, you look at the parentheses and the exponents, and you will multiply them together. You can almost think of this like distributing exponents, like some of your factoring problems. So we rewrite this as 4 to the power of 6, because 2 times 3 is 6. For part B, we have a similar problem of 5 to power 3, all to power 4. We are going to multiply our exponents together, giving us a base of 5, all to the power of 3 times 4, which is 12. Okay, and for example, in the previous problem, I mentioned distributing. So if I had 2 to power 3 times 3 to power 4, all to the power of 5, you would again distribute and multiply the exponent to everything inside the parentheses. So this would give us 2 to power 15 times 3 to power 20. Okay, now that we understand that, let's move on to some negative exponents. With 7 to negative 1, all raised to the power of 5, you can use the same rules as before, which is going to be to multiply the exponents, or you could take the reciprocal, and that would make the negative 1 a positive 1. Let's try both. So to get started, we have negative 1 times 5. So this can be rewritten as 7 to the negative 5. Let's say instead we wanted to do the reciprocal. So flipping this, we get 1 over 7 to the positive 1 now, all to the power of 5. Okay, from previous problems, we know we have to distribute to everything, so we're going to have to distribute the 5 to the upper and lower numbers. Rewriting this, that gives us 1 to power 5, all over 7 to power 5. And knowing that 1 to power 5 is simply 1 over 7 to power 5. And like we talked about in the first slide, these two numbers are the same. Moving on to part D, we can see that it's getting a little bit more complicated. So let's write this out. We have 4 to the power of 2, all to the power of 5, divided by 8 to the power of 2, all to the power of 3. Like you know from orders of operations, we want to simplify the parentheses first. So let's treat the top as its own value first. So 4 to power 2 to power 5 gives us 4 to the power of 2 times 5, which is 10, all divided by, the same idea applies down here, 8 to the power of 2 times 3, which is 6. All right, now we need to simplify this even further. So let's rewrite 4 and 8 as the number 2, but with exponents. So 4 is the same thing as 2 times 2. Again, this is all still to power 10, which is the same thing as 2 to power 2, all to power 10. Now let's look at the bottom. 8 is the same thing as 2 times 2 times 2, and that's still to the power of 6, which we can rewrite as 2 to the power of 3, all to the power of 6. Okay, this fraction is basically the same problem we started with, just with things broken down a little bit further. So let's simplify. Again, we will multiply our exponents together to give us, for the numerator, 2 to the power of 20, all divided by 2 to the power of 18. And as you learned in some of our previous videos, these exponents will battle each other. The bigger number always wins, so the number on top stays alive, and 20 minus 18 gives us a positive 2 all over 1, which we don't have to write. So 2 to the power 2 is the same thing as 4. And that's your final answer. So we started with part D, and for the first step, we addressed the parentheses by distributing the exponents and multiplying them together. Then, as we started to simplify, we realized that we could reduce the bases into exponents as well, and then we repeated the process. We distributed exponents and then simplified to get our final answer of 4. Looking at part E, we will use a similar approach to that of part D. We have 4 to power 2 to power 3 times 16 to power 2 to negative 1. Rewriting this by multiplying the exponents together, we get 4 to power 6 times 16 to the negative 2. Since we have a negative exponent, we know that we can take the reciprocal of 16 and make that negative 2 a positive 2. So we have 4 to power 6 over 16 to power 2. Now let's rewrite this so that the bases match. We have 4 to power 6 all over 4 times 4, which is 16 to that power of 2. Again, this is 4 to power 6 over 4 squared to the power of 2. All we did was simplify 4 squared and 4 times 4. Multiplying those exponents out, again, we get 4 to the power of 6 over 4 to the power of 4. And now we have one of those simplified fractions where we can cancel out the exponents, leaving us with 4 to the power 2 over 1, which is going to be 16. You'll notice in this one, I didn't reduce the 4 all the way down to a base of 2. The reason I did that was because both of these share a common base of 4, so you don't have to reduce it further as long as everything matches. But if you chose to go all the way to a base of 2, you would still get the same answer. As always, thank you so much for watching. I hope you learned something, and if you have any questions, feel free to drop it in the comments.